Hi, welcome to our study of variables and expressions. We've worked with these a little bit throughout the semester. Now we're going to look at them in a little more depth. But before we can work with them, we need to be able to talk to each other about them. So let's talk about some definitions and some examples first. When we talk about variables, we are talking about a letter, that takes the place of a number. Typically, you're used to seeing X and Y, but when you move beyond basic algebra, you start to see things like H and T that typically get used for height and time. Sometimes we use D to represent distance, R to represent rate. You may be familiar with using a little m to represent slope. So a variable is any letter that takes the place of a number. Now, we take those variables and we combine them with numbers and symbols to create an expression. An expression is a mathematical statement combining variables and constants. Remember that constants are just numbers. We refer to them as constants because their value doesn't change. 3 will always be 3. It will constantly be 3. We're not going to change that. So an expression is a mathematical statement combining variables and constants with operations. Now, no one's getting their appendix taken out. What we're talking about is things like addition, subtraction, multiplication, and division. Notice I did not include equals. We are not including equality in our expressions. Once you throw in equality, that throws us into equation territory. You're not quite old enough for that yet. An example of an expression could be as simple as 2x. Or maybe we want to talk about the perimeter of a rectangle. We're not going to use an equals. Maybe we just say 2 times the length plus 2 times the width. That's an expression. It doesn't contain an equal sign. Maybe we have negative 3x plus 4y times 6. That's another example of an expression. The last thing we need to be able to do is evaluate. Evaluate is a fancy way to say substitute values for their assigned variable and calculate. So you might see a problem that would say for x equals 4 and y equals -3, evaluate 2y minus x. So I told you before, we're going to substitute values for their assigned variable. So I'm going to start by rewriting the problem, but I'm going to leave a hole where my x, or where my y goes, and a hole where my x goes. And for the x, I'm going to substitute a 4. For the y, I'm going to substitute a -3. Then I compute. You can go to Desmos to do this. You can do it by hand. It is totally up to you. 2 times -3 is -6. -6 minus 4 is -10. So if you were asked to evaluate, this would be your final answer. So let's look at a couple of these. We want to evaluate each of the expressions using the values given. So what I'm going to do is I'm going to go through and I am going to create holes where my variables are. And I know that n is -2. So I'm going to put a -2 in the n spot. Then I need m as 5. So I'm going to put a 5 in the m spot. Now, if you want to, again, please use a calculator if you aren't super confident in your arithmetic abilities. -2 squared is a +4. 4 minus 5 is -1. I don't know where my square went. There we go. So if we go look at 2, I'm going to end up stacking parentheses, and that's okay. I want to create holes where my x and my y go. So this would be 8 times whatever I substitute for x minus whatever I substitute for the y. Now this tells me that x is 2. So I'm going to plug a 2 in the x spot. Y is -3. So I'm going to put a -3 in the y spot. Two minus -3 means that these two negatives are going to make addition. So I really have 2 plus 3. And 8 times 5 is 40. If we look at 3, I need M and P. So we'll grant P a color here. not pretty, but I haven't used it yet, so we'll use this guy. I'm going to make holes for my M and my P. And a lot of people say, Miss Graham, why do you make the extra parentheses? Because there are some instances where if you don't put your numbers in parentheses, life gets hard. So it is a fabulous habit to adopt. When you are evaluating expressions, functions, anything, that you get in the habit of using parentheses anytime you evaluate. So M is green. M gets a 5. P is brown. It gets a 6. You can, from here, go put this all in the calculator. We haven't talked about order of operations yet, but it's coming. Order of operations says you do the parentheses first. So that means I would combine the 5 and the 6 first. That would give me 15, minus 11. And that gives me a final answer of 4. Five is division. I'm still going to create holes for my X's and Y's. X is blue. So I will give X a blue number 2. Y is negative 3. So I will give Y an orange negative 3. Now, when you go and plug this in a calculator, please, please, please make sure please hold while I figure out what's going on with my iPad. That was weird. Okay. We are going to be very careful when you plug this in your calculator. I'm going to go get Desmos real quick. Now, when I go and plug this in Desmos, I prefer to start with my fraction button and then plug it in just like it looks. And it works just fine. But here's what happens when students get in a hurry and they don't pay attention to what they're plugging in. Put that back up there and we'll get an enter for a clean line. Now, a lot of people will do 2 times negative 3 divided by 2. That one worked okay. Sometimes, if we have maybe an addition problem, they might do, so let's say we had 2 plus 3 divided by 2. They get in a hurry and they do 2 plus 3 divided by 2. When they plug that in, they plug it in fast and they don't pay attention to what they're doing. If you plug it in the way it looks with the 2 plus 3 in the numerator and a 2 in the big denominator, 3.5 and 2.5 are very different numbers. So please, please, please be careful when you plug numbers into Desmos, especially when you're working with fractions. We'll look at one more. Let's look at n over 6 plus 2. I'm going to make a hole for my n. N gets a pink negative 2. I go over to Desmos and I plug it in just like it looks. Now, if you leave this answer as 1.66 repeating, that is perfectly acceptable. The other option would be to change it to an improper fraction. So both of those are completely acceptable responses. Now let's go write some of our own expressions. Ms. Graham is planning a garden that is 3 feet wide. She isn't sure how long she's going to make it, but is considering 10 feet, 11 feet, or 12 feet for the length. We've got a length and a width. So that tells me that I'm going to be building a rectangular garden. I know it's 3 feet wide. I know that the length could be 10 feet or 11 feet or 12 feet long. We're going to enclose this garden in fencing to keep her dogs out. If L is the length of the garden, she will need L plus 3 plus 3. So that's length plus length plus the width plus the width. If we combine the two L's, we get a 2L. 3 plus 3 is 6. So I would need 2L plus 6 feet of fencing. How much will she need for each possible garden length? This is an evaluate question in disguise. What this really says is evaluate (2L plus 6) for L equals 10 feet, 11 feet, or 12 feet. So I'm going to start with 10 feet. If my garden is 10 feet long, that means I would need 2 times 10 plus 6, or 26 feet. Of fencing. So now I'm going to check out 11 feet. And I'll be careful. It looks like since we're adding 1 more foot to the length, we just need to add 1 more foot to the total. But that's not the case. When you evaluate your expression at 11, we're going to plug the 11 in the L spot. That's 22 plus 6, so that's 28 feet. The last length that I'm considering is 12 feet. So I want to evaluate my expression when the length is 12. 2 times 12 is 24, plus 6 is 30 feet. So when I go to buy fencing, these are all of the possible lengths for fencing that I need to purchase to complete my project. Okay, the next one says the Math 0300 class is getting ready to begin a study of graphing. They want to create a table of values for the equation y equals negative 2x plus 1. If they use the numbers 0 through 5 for their values, find the y values that go with them. Now, a long time ago, in a galaxy far away, you learned to graph. For some of it, it has been a whole lot longer than others, but that's okay. The first thing I am going to do is I'm going to shorten this to be from 0 to 5 to maybe 0 to 3, because it's going to get old. So what I'm going to do is translate this. This says evaluate 2x, negative 2x, plus 1 for x equals 0, 1, 2, and 3. I'm going to make a table. I'm going to make an X column. And I'm going to make an evaluate column. And it's going to give me a Y value. That's what we're going to call our answers. So when X is 0, 1, 2, and 3, we're going to evaluate our expression. Well, when X is 0, I'm going to make a hole for my 0. Negative 2 times 0 is 0, plus 1 is 1. Then I'm going to evaluate my same expression at each of the other X values. So when X is 1, I'm going to plug a 1 in the X spot. Negative 2 times 1 is negative 2, plus 1 is negative 1. If I evaluate the expression for X equals 2, I plug a 2 in for X. Negative 2 times 2 is negative 4, plus 1 is negative 3. Then if I evaluate for X equals 3, negative 2 times 3 is negative 6, plus 1 is negative 5. So each of those Y values would be our answer for evaluating the expression for each of the different X values. Last one, we have a t-shirt company charging $32 to set up their equipment, and they are going to charge $7.50 per shirt that they sell. The total cost for T-shirts is given by C equals 32 plus 7.5 T. Well, already I know that this is the cost, and this is the number of shirts. I like to label my stuff, y'all. What is the cost? So that says, what is C when T is 30 shirts? All that is a fancy way to say evaluate 32 plus 7.5 T for T equals 30. That's all they're asking you to do. They're asking you to create a hole for the T and plug in that 30. Then you go do the math. This one is definitely sending me to my calculator. I don't do mental math well at all. So my cost would be $257 for 30 shirts. That is the end of our brief look at evaluating expressions.